Explore DNS traffic. Explore domain name service traffic. You will install Wireshark on a Windows system and use Wireshark to filter for DNS packets and view the details of both DNS query and response packets. Required resources: one Windows PC with internet access and Wireshark. Capture DNS traffic. Open Wireshark and start a Wireshark capture. Wireshark. Okay, now you can see my Ethernet interface is the active interface. You can see the traffic here, but also you can use Wi-Fi if it's the active interface. In my case, the active interface is Ethernet because this is the traffic. Okay, and double click here. Okay, very good. Command prompt, enter ipconfig/flush DNS to clear the DNS cache. Okay, command prompt, ipconfig /flush DNS, enter. Okay, we successfully flushed the DNS resolver cache. Enter NSLOOKUP up the prompt. NSLOOKUP, enter. Okay, in my case, the DNS server by default is this IPv6 DNS server. And resolve this name, www.cisco.com. www.cisco.com. Okay, unknown. I'm trying to resolve this name, Cisco, www.cisco.com, using this IPv6 DNS server. Cannot find this name. And you need something like this. Okay, and if you have the same problem, exit and NSLOOKUP www.cisco.com and use the IPv4 DNS server of Google. Okay, you can use the IPv4 DNS server of Google to resolve www.cisco.com. Enter. Very good. The server is the DNS of Google. The address is this. The name of www.cisco.com is this name. The addresses, IPv6 addresses, and one IPv4 address for this name, cisco.com, and aliases. Okay, very good. And also you can use the IPv6 server of Google, the IPv6 DNS server of Google, 2001/4860:4860:/ and 8888, enter. Very good. The same result using the IPv6 server of Google. Stop capturing packets. Okay, on Wireshark, click here on the red square. Stop capturing packets. Click here. Very good. Explore DNS query traffic. Observe the traffic captured in the Wireshark packet list pane. Enter UDP.port equal 53 in the filter box and click the arrow or press enter to display only DNS packets. Okay, port 53 of UDP protocol. UDP.port space equal space 53. Okay, and enter or click here on the arrow. And you will show only DNS protocol because DNS uses port 53 and UDP protocol. Select the DNS packet labeled standard query, the hexadecimal number 0002 a www.cisco.com. A standard query hexadecimal 0002 a www.cisco.com. Okay, and remember the packet list pane. The packet list pane is this section. This section on top. Okay, packet list pane. And packet details pane is this middle section. Packets detail pane. Notice this packet has Ethernet 2, Internet Protocol version 4, user datagram protocol, and domain name system query. Okay, click here on standard query 0002a www.cisco.com. Click here, and you can see Ethernet 2, Internet Protocol. In my case, is version 6. Okay, don't worry if Internet Protocol is version 4, don't worry. In my case, is Internet Protocol version 6. User datagram protocol and domain name system. Expand Ethernet 2. Observe the source and destination fields. Expand this Ethernet 2. Okay, also expand destination and source. Destination is this MAC address, and source this another MAC address. What are the source and destination MAC addresses? Which network interfaces are these MAC addresses associated with? The source address is this 54AB3A5BAD04. Okay, will vary in your case, but for me is this, and this is the and this MAC address is associated with the network interface card on my PC. And you can do the following: ipconfig/all, enter, and this is my Ethernet interface, my Ethernet adapter, and you can see 54AB3A 5BAD04. Okay, this MAC address. the MAC address of my Ethernet interface on my PC. If you selected Wi-Fi interface should be the MAC address of your MAC address of your wireless adapter. Okay, and destination MAC address is the MAC address of your default gateway. Okay, the destination MAC address is associated with the default gateway. And you can do the following. ipconfig. My default gateway is this 192.168.1.1 192.168.1.1 and ARP option A, enter. And the default gateway 192.168.1.1, my default gateway has this MAC address F4, 4B, 2A, EB, A3, and B3. And is this F4, 4B, 2A, EB, A3, B3. Is the same. Very good. Expand Internet Protocol version 4. Observe the source and destination IPv4 addresses. Okay. Hide Ethernet 2. Expand Internet Protocol version 4 or 6. In my case is 6. And this is the source IPv6 address, and this is the destination IPv6 address. Okay, the source address is the IPv6 address of my Ethernet interface. Okay, the IPv6 address of my Ethernet interface, this. The temporary IPv6 address. Okay, is this. And if it is IPv4, should be this. And the destination IPv6 address is the IPv6 address of the DNS server. But remember, this DNS server in my case failed. Okay, and you can search the next standard query 0002 www.cisco.com, and it's this standard query 0002 www.cisco.com. Okay, Ethernet is the same, source, destination the same. Hide this, Internet Protocol version 4 in this case, and source is the IPv4 address of Ethernet interface, and destination the IPv4 address of the DNS server. Okay, because because this is the query. Expand user datagram protocol. Observe the source and destination ports. Okay, hide Internet Protocol version 4 and expand user datagram protocol. Okay, the source port is dynamic port 62,911. Okay, and will vary. In my case is this, and destination port 53. Well-known port 53 for DNS domain name and service. What are the source and destination ports? What is the default DNS port number? Okay, the source port is dynamic port, destination port 53, the default DNS port. Open command prompt and ARP-A and ipconfig all to record the MAC address and IP address of the PC. Okay, ARP-A, ipconfig all. Enter ARP-A, ipconfig /all. Okay. Compare the MAC and IP addresses in the Wireshark results to the results from the ipconfig all results. What is your observation? Okay, the expand Internet Protocol version 4. The source IP is the IP address of my Ethernet interface, 192.168.110, and Ethernet source, Ethernet 2 source is this, 54AB3A5B AD04. And ipconfig all, Ethernet interface, my IP address 192.168.110, 54AB3A5B AD04. Okay, very good. The IP and MAC addresses captured in Wireshark are the same as the addresses listed in ipconfig all. Okay, and on Internet Protocol version 4, the destination is 8888. And on Ethernet 2, the destination MAC address F44B2A-EB83B3. Okay, is this okay? Is this F44B2A-EB83B3 the MAC address of the default gateway? Okay, so the MAC address captured in Wireshark is the same as the address listed in ARP table, and this MAC address belongs to the default gateway 192.168.1.1 in my case, and the default gateway will permit to reach another network on Internet and reach destination 8888, the DNS. Expand domain name system query in the packet details pane. Okay, here hide Ethernet 2, hide Internet Protocol version 4, hide user datagram, expand domain name system. Then expand the flags and queries. Flags, queries. The flag is set to do the query recursively to query for the IP address to www.cisco.com. Okay, look at this. Recursion desired, do query recursively. Flag is 1. Any other 0. So this is a query. Explore DNS response traffic. Select the corresponding response DNS packet labeled standard query response 0002A www.cisco.com. Okay, is this standard query response 0002A www.cisco.com? What are the source and destination MAC and IP addresses and port numbers? How do they compare to the addresses in the DNS query packets? Okay, select this, the response, go to Ethernet, destination is 54AB3A 5B8004. Now the destination is the MAC address of the Ethernet interface on my PC. Source F44B2A EB83B3. So the source is the MAC address of the default gateway F44B2A EB83B3. Expand Internet Protocol version 4. The source is now the DNS server of Google 8888, and destination now is the IPv4 address of my Ethernet interface 192.168.110. Okay. User datagram protocol. The source port now is 53, the DNS port, and the destination port is the dynamic port on my PC. The source IP, MAC addresses, and port numbers in the query packet are now destination addresses. The destination IP, MAC address, and port number in the query packet are now the source addresses. Okay, everything reversed. Domain name system response, expand flags, queries, and answers. Okay, hide internet, hide user datagram, expand domain name system response, expand flags, expand queries, and expand answers. Can DNS server do recursive queries? Okay, look at this flag in 1, recursion desired. Do query recursively? So the answer is yes. And another this flag, recursion available. Server can do recursive queries. Observe CNAME and A records in the answer details. How do the results compare to NS lookup results? Okay, look at this. Okay, this is CNAME, 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 and CNAME. The aliases 1, 2, 3, 4 aliases CNAME. Okay, and go to NS lookup. Okay, NSLookup www.cisco.com, the IPv4 DNS of Google, the IPv4 DNS of Google to resolve this name. You can see this 1, 2, 3, and 4 aliases. CNAME 1, 2, 3, 4, and finally the A record type A, and will resolve this name to this IP address. Okay, and you have this address. The results in Wireshark should be the same as the results from NSLookup in the command prompt. But where are the IPv6 addresses? Okay, you can find this. Select this. The standard query is 0003 AAAA www.cisco.com, and this is the response. Standard query response 0003 AAAA www.cisco.com, and expand domain name system. Okay, and now you can see type AAAA, this IPv6 address, and this another IPv6 address. Okay, the resolution, but for IPv6, and is this IP and this another IP, IPv6 addresses. From the Wireshark result, what else can you learn about the network when you remove the filter? Okay, remove this filter. Okay, to remove this filter, only press the X. Okay, and no filter. Okay, and now you can see any other protocols like ARP, TLS, UDP, SSDP. Okay, TCP. Okay, without the filters, the results will display other packets. From these packets and the information contained within these packets, you can learn about other devices and their functions within the LAN. How can an attacker use Wireshark to compromise your network security? An attacker on the LAN can use Wireshark to observe the network traffic and can get sensitive information in the packet details if the traffic is not encrypted. Okay, for example, ARP, click here, is not encrypted because you can see the contents of the address resolution protocol. Okay, these contents, or maybe on DNS, you can see the domain name system, the query, or the response. Okay, but this is an encrypted packet TLS. if you go to transport security, now this data is encrypted. Encrypted application data. Thank you very much.